Hi, Year 12. Tonight, I'd like to review the 2024 Independent Trial HSC that I set. And I was reasonably pleased with the results because we got a mean of around about 52, which indicates that the exam was pretty fair. So let's just go through the multiple choice first. Manual lifting has largely been replaced by mechanical lifting devices. And the significant change is the development of hydraulics and materials technology. So A is the correct answer for 1. 2, question 2, which of the following is the thermosetting polymer? Normally, you can see that any polymer where you need to mix a resin and a catalyst is a thermosetting polymer. And epoxy resin, as you know, is araldite, and that's the thermoset. Nylon, acrylic, and polyvinyl chloride are all thermoplastic polymers. So this is the thermosetting one. Which best describes the angle of repose? Now, the angle of repose is the angle at which the slope will produce initiation of movement of the body on the slope. So the angle of the plane when sliding begins. And this is how you derive the angle of repose with a block on an incline. You've got the force acting down, which is the weight force, which is mg sine theta, acting down. And you've got your force of friction acting up, which is mu n. And the normal is mg cos theta. And that's worked out from the triangle underneath the block when you derive the normal and the force down the plane. So you sum the forces up and down the plane, and we say up is positive, so minus mg sine theta goes down. Force of friction goes up, which is mu mg cos theta, because it is mu n. And so that equals 0. You get the equation in terms of mu, coefficient of friction, which equals sine over cos, which is tan. So the tangent of the angle of repose is equal to the coefficient of friction. Question 4, what's the greatest mass that can be lifted by the 10 kilogram mass in the hydraulic system? So you've got a 10 kilogram mass at the effort here, and this is the load here. So at 100% efficiency, if the question doesn't say what the efficiency is, you always assume it to be 100%. Mechanical advantage equals velocity ratio, and velocity ratio of a hydraulic system is the large diameter, the output diameter squared over the input diameter squared. And you remember that by big phi floats on little phi. And so that's 100 square because the output piston is 100, the input piston is 20, and it works out to be 25, which equals the mechanical advantage, which is load over effort. Now we know the effort is 10 kilograms. Now you can't say a mass is an effort, but you just multiply it by 10 so that you convert that to a force. But there's no need to do that because they're in the same ratio. And so you've got a load of 250 kilograms, and D is the correct answer there. Which metal test determines a material's notch toughness? The only sample here that has a notch put in it is the impact test, where it initiates failure because of a stress razor. And so the Sharpie test is the answer there. There's the other test, the other impact test is the ISOD test. Question 6, which material is best used for electrical connectors? Now, this is one of the things that you've just got to learn. This is on page 122 of my book. And I think it's about 0.7% beryllium in copper. And it's a alloy that doesn't spark on contact, and that's why they use beryllium copper. 7, a magnet rotates in alternating current generator is shown. Which position of the rotating magnet produces the maximum positive voltage? So the rotor is going clockwise, and as it goes through this magnetic flux here, it produces a positive current. And as it goes back through, that will be the negative, and so B is the correct answer. Grain flow or grain orientation occurs in which industrial forming process? The forging, rolling, hammering, you'll get grain flow, but in no grain flow in casting, not much in welding. In fact, there's no continuous grain flow in welding. Powder forming, no grain flow. Annealing is heat treatment, and casting once again, and these two are hardening and tempering are heat treatment. So A is the correct. The second stage in precipitation hardening process is to quench the alloy to room temperature. What's the purpose of this stage? The idea of heating the alloy up is to get a uniform structure, a homogeneous structure, so that when it cools, the particles will gather in zones and will strain the bonds, which results in it becoming harder, less ductile, and tougher. So to retain a uniform structure is the answer there. Which of the following methods would be appropriate method of protecting the steel hull of a boat against corrosion? You've got to use a reactive metal, more reactive than the hull itself, as a sacrificial anode. Question 11, what industrial process would be most suitable for the manufacture of an industrial hard hat? Look, when you're asked a question like this and it involves a polymer and you don't really know it, have a guess. It's injection molding is by far the most ubiquitous polymer molding process. So yeah, just guess at injection molding if you don't know, and you're probably correct. So C is correct here. What are the main reasons why carbon fiber epoxy composites are used for aircraft control surface, such as spoilers and ailerons? Now, spoilers and ailerons are components of wings, and you really don't want them to flex. And so you're looking for rigidity. And carbon fiber epoxy composites have high specific strength, but in these applications, these control surfaces on an aircraft, they have to be very rigid because they don't want to give false readings by twisting. And so rigidity you're looking for, and it's also got high specific strength. So A is the correct there. Which of the following is an essential property of the fluid used in hydraulic systems? Now, as you know, pneumatic systems involve liquids, and they're nowhere near as positive as hydraulic systems because the fluid, which is a gas in pneumatic systems, compresses, and so you don't get a positive movement. You get bounce in it. So you're looking for low compressibility, and liquids have very, very low compressibility. So C is the answer there. The gang-nail timber roof truss is shown. Now they call the gang nailing is the method they use to join the members of the truss, and gang nails are just holding the members in place. If you applied a moment at that joint there, it would just tear the gang nails out. And so these trusses are designed as though each join is a pin joint so that it cannot resist a moment. And the reason why they design it that way is so that you only want tensile or compression forces in these members. You can't have bending in them because they're so slender. And so that's why a truss is designed on the basis of the joints are pin jointed. So that's D, all joints are considered to be pin joints. 15, what's the purpose of a pitot tube on an aircraft? It's to determine the speed of the aircraft. The altitude is an altimeter, which a lot of you said. The electrical circuit shown has 3 resistors and a 24-volt power supply. What's the total resistance of the circuit and the power consumed at the 3-ohm resistor? Well, these resistors are arranged in parallel. So you use the parallel formula here and you get a total resistance of 0.55 ohms. And to get the power, like you look down here and you're pretty sure that it's D here, but if you want to, you can work out the power. Power's voltage squared over resistance, and it's 192, so the answer is D there. So here we have a 4-stroke system, and you should learn this. The first is the intake, second compression, third power, and fourth exhaust. And so C is the answer there. Question 18, a phi 20. Make sure you know that phi is diameter, 20 volt. They don't ever use millimeters. They don't ever write down millimeters because that's the standard. If it's meters, they will write down meters, but I've put millimeters in here because it's caused some problems with students. We're not testing the nomenclature so much as we're testing your knowledge of how to work the question out. So I put millimeters in there. So there's a fair bit of spurious information in this, which is a good test to see whether you know what you're doing. So you know that strain is the change in length, and they use delta for change in length over the original length. It extends 0.2 millimeters, and you've got to have millimeters over millimeters. So you've got 100 there, and it is 0.002, and that's millimeters per millimeter. And you multiply that by 100 and you get 0.2%. So B is the answer there. Which of the guided transmission media has the highest transmission rate and lowest attenuation? Single mode optical fiber is the most ubiquitous optical fiber that's being used now because it's very efficient and has a very high transmission rate and low attenuation. Attenuation is the loss of signal. 20, which best describes the effect that tempering has on hardened steel? Hardened steel is if it's greater than 0.3% carbon, it has sufficient carbon in it for martensite to form. And if you temper the martensite, martensite is very hard and it's very brittle. You replace that brittleness with toughness. So D is the correct answer there. Question 21A, describe friction in engineering offers both benefits and drawbacks to society. Describe 2 advantages. Now you've got to describe them. You just can't name them or you can't list them. You've got to describe them. You've got to make a statement and then justify that statement. 2 advantages and 2 disadvantages to society of friction. Now it's got to be to society. So it allows stability while walking. So there's your statement. Due to the frictional force between shoe and pavement, provides stability to motor vehicles due to the frictional forces generated when accelerating and braking. So that's a description. of the advantages. The disadvantages: frictional force absorb energy from machinery, and here is the qualifying aspect, which makes machines less efficient. Frictional forces cause wear in machinery, and this is a description because you've got this qualifying statement here, which is costly to consumers. Okay, name a field in engineering where friction has been lessened and explain the technique employed for its minimization. So here's a good example: mechanical engineering, like the internal combustion engine, has massive amount of friction because you have pistons inside cylinders, and the friction is reduced tremendously by the use of lubricants which adhere to the moving surfaces. They've got a special molecule that will adhere to moving surfaces and reduces the amount of friction, so therefore increases the efficiency of the machine. This was an easy question. You just say you've got a block, 800 kilogram, is at rest on a horizontal surface. Force F is applied to the block by means of a cable. And always assume acceleration due to gravity to be 10 meters per second squared. Don't use 9.8, use 10 in engineering. Determine the force F required to just move the block, and the coefficient of static friction is 0.1. This is out of place here, I don't know why. And so you know that the force left has to equal the force right. The force left is F, and the force right is friction, which is mu n. So you say sum of the forces in the x direction equals 0, with that direction positive. And so you get for F equals mu n, which is 800 newtons, which is a very easy question, indicated by this mark here. A bit more difficult. This is worth 3 marks. When the force is inclined to 30 degrees, you've got to determine the force required to just move the block. Now you can do this graphically. You know that the angle between the normal and the force of friction, the resultant of the normal and the force of friction, and the normal will be the angle of repose. So you say tan phi s equals mu, which is 0.1, so therefore phi s is equal to 5.7. So phi s is the angle between the resultant of the normal and the force of friction and the normal. So that angle in there is 5.7 degrees. And so you use Bose notation, and you can get a force diagram here, and you can use graphics. And remember, you get 10% leeway if you use graphics. You can draw this accurately, but it's got to be drawn accurately. 10% isn't much in graphics, so make sure you draw it accurately and use your set squares. And so the force will be 873 newtons. Do it analytically. You say the sum of the forces in x direction is 0 and right is positive. So you've got F cos 30, which is the horizontal component of F there. And that will equal the force of friction, which is mu times n. Now, it's n isn't 8,000. You've got to take off the vertical component of that force. And so, and the vertical component is F sine 30. And you've got one unknown in the equation, so you can find out what F is, and it's 873, same as what we got over here. Of course, this was done on a CAD system, so you get the exact same answer. This gave everyone except 1 or 2 heaps of trouble. So you've got a conventional timber truss. This is the truss that's probably in your house. And you've got one force there. So when you look at a question like this, and you see that you've got to do the reactions. You've got a force there, a force there, and a force there. There's three forces, and this is the way that I would do it. I'd use the three-force rule. We'll go through this in a minute. So what you've got to do is, we'll do it analytically first, and then I'll do it the graphical representation. So here you have a pin, and you know that a pin can resist a moment. So it will have horizontal and vertical component forces in it if you've got horizontal and vertical forces acting. But this one here is a roller or a slider. And if I were you, I would draw a force up here, and I would make sure that it is drawn like this. Put an arrow there. Tell the examiner that you know that that is 90 degrees, and you will more than likely get 1 mark, depending on the other students. So you've told the examiner that you know that a force, reaction force at a slider is at 90 degrees. Now, straight away, you know that this force here, which is the horizontal component, will equal the horizontal component of that force there. And I would draw this in, and I would call it R, L, X. And you know that this force here will be, because that's 30 and that is 60, this angle in here will be 30. So this force here will be 10 cos 30, which will be 8.66 kilonewtons. And I would be showing the examiner that I know that that is equal to that without having to do this here. So I'd just be putting 8.66 kilonewtons here, because you know the last statement is on a marking scale is demonstrates some knowledge of the question. Okay, and then this force up here, you get that there, so that force there will be R, L, Y. And then you immediately know that the RL will be somewhere down here, and that will be theta. Okay, so to find RLY, you can say the sum of the vertical forces, like I've done here, sum of the vertical forces, and you get 2.5 going up. Some of the horizontal forces, you don't have to do this. I've just done that there. So this, some of the vertical forces, this force here going up here will be 10 sine 30, which will be 5 kilonewtons there. And so we've got RLY, which is this force here, minus 5, which is that force there coming down, minus 2.5, which is this force going up here. This RR is 2.5. And then you use Pythagoras, that squared plus that squared equals the square of that, which we've got, which is 9 kilonewtons. And then tan theta will be RLY over RLX, which is 2.5 over 8.66. And so you've got that there. But this is the way that I would do it. You use a three-force rule. So you've got a force going through there, you've got a force going through there, you've got a force going through there, and you just, you know, this is vertical, so you project that up there. There's your point of concurrence, and you've immediately got the angle of the force going through RL. And then you just do your force triangle. So here's your forces here at the point of concurrence, and I've just used Bose notation, X between those two forces, Y between that one, and Z goes all the way around here. And so you start with the known force, which is X, Y. There, I always start from the point of concurrence, then go clockwise. It'll be this force here will be parallel with that one. And then this last force has to go through that point, has to be vertical. And so you've got that distance there. And you just scale them off, and you should get pretty close to what you've got here. So that's how you do that question. And I was a bit disappointed because that's not a difficult question, and it's worth, although it's worth 5 marks. So make sure that you practice those. Now, this is a difficult question because you can see that it's worth 7 marks here. And so you've got to find the force in member A, member B, member C, and member D over here. Now, straight away, member D, you know, is a redundant member, because if you did a force diagram here, you would have the force going up, then the force going back, and then this force here would have to be a point on the line. So therefore, there's no force in that member. It's a redundant member. And that's all you need to do here. Force in D, no external force applied to the joint, therefore D is a redundant member. But let's do these forces. So you tell the examiner that you're going to take the right-hand side and assume all members are in tension. Now, so there's your section going through there. And we're going to take the right-hand side. So this whole section here will be in equilibrium, and this part here is removed. So we want to find the force in A, but we want to get rid of B and C to do it. And so the first place you look for is where those two forces meet, and it's Z here, and make sure that you annotate that so the examiner knows where you're taking moments about. So we're saying the force in A, so we're saying the sum of the moments about Z equals 0 with clockwise positive. So we've got A times 1.5. Now you can work that distance out using trig, or you can scale it off the diagram. And I've shown you how to do that when I visited you last time, so you should be able to do that now. And it's a good way of doing it because all of your diagrams will be drawn to scale. If they're not drawn, they will be drawn to scale in the HSC, because at one stage, a couple of years ago, they didn't, and it wasn't well received. So all drawings will be drawn to scale in the HSC. So they should be. So we've got A times 1.5, and we're saying it's in tension, so the force is going up, it's away from the joint, so that's a negative direction. We've got 5 times 0.75, and we're taking moments about that point, so we've got 5 coming down here, and that distance is 0.75, and you can work that out with trig, or you can scale it. And then you've got 8.66 times that distance there, which we worked out on the previous question, which is 1.3, minus 2.5 from the previous question, times 3. and that equals 0. And so you get a negative answer here, and that indicates that our guessed tension is compression. Now, the next part, force in B. So you say sum of the moments about Y equals 0. Now make sure that you show where Y is. Now we're using Y because we want to get rid of that force and that force. We want to find the force in B. And so we've got 5 times 2.5. So that's 5 times 2.25 there. And that's going to go anti-clockwise. So it's negative, minus 8.66 times 1.3 minus that distance, that force times that distance there, which is 1.3. And that will be going anti-clockwise about this point here. So it's negative, minus B times 2.6. So we've got B here multiplied by 2.6, which is that distance there. And so we get B is equal to positive 9.1 kilonewtons, and it's tension because we've assumed that to be tension pulling away from the joint, and we get a positive answer, so it's right. Now the force in C, for some of the moments about X, we're going to find C here with this one here. So we're going to take moments about that joint there. And it's a simple equation because we're taking moments about that joint. The moment of all those forces about that joint are 0, and about the forces going through B and C, it's 0. And so we've got C times 1.3. That's that distance there, times 1.3. And we're assuming that that's in tension, so it's going to go positive, minus 2.5 times that perpendicular distance, which is 2.25. It's going anti-clockwise, and we get positive 4.3 kilonewtons, so therefore it's in tension. Okay, I hope you can do that because that's a lot of marks. Next question, question 23, explain the function of the aerial. Most of you got 1 mark for this because you didn't say it produces a small current in the area. When the electromagnetic wave hits an aerial, it induces a small electric current in it. Explain the function of the tuned circuit. Now, if they can get the tuned circuit on the same frequency as a carrier wave that you're after, you will tune in to that frequency. And so the tuned circuit is tuned to pick up the frequency of the carrier wave. And you have variable inductors and variable capacitors to get the current at the same frequency as the carrier wave that you want. And you can use a dial or a knob to turn that, or you can use the latest electronics to dial into the resonant frequency. Explain the function of the demodulator. The demodulator separates the information wave from the high frequency carrier wave, and it discards the carrier wave because we're after the information wave. Explain the function of the audio amplifier. Because the signal is so weak, the current is so weak, you need an amplifier to amplify the frequency that comes from the demodulator. Explain the function of the speaker. The speaker changes an electrical signal to a sound wave, which we can hear, an analog sound wave. Name the most common polymer used to insulate electrical cables. Everyone should know this is polyvinyl chloride, it's PVC. Same material they use for downpipes, plastic downpipes and guttering, PVC. Now this you had to draw the true shape of this. So here's your front view. There's your top view. This is a piece of metal with a hole cut out. Now, this is how you should have done this. You should have realized, you ask yourself, is that line there a true length? You look in the other view and you see that it's horizontal. So therefore, that is a true length. So the whole thing here, if you project lines up here, each of these lines here are true length. Now, if you can get the height as a true length, and you ask yourself, is AB there a true length? And you look here and you see that it's a point there. So therefore, all these lines here, these vertical lines, are true length. And so all you had to do is put your compass on this distance here, and you'll get the size of AB. You go from C down to there, that'll be your height there. And so you know that that is the height there, and that's a true length. And that's how you do it. Now, how do you get the circle? Now, the circle here is a bit of an ellipse there, but you know the true length of where it sits. There's the center line of the true length going up there, of the center of the hole. And you know that that distance there is a true length. So you just mark it there, and that'll be the center for your hole. Now, how do you get the diameter of the hole? Well, you know that there's a major axis of an ellipse and a minor axis of the ellipse. And when you rotate the ellipse, the minor axis doesn't change. And so therefore, that is the true length of the diameter. And so you just mark it here and there, and then just draw a circle. And so you've got the true shape of that face. Next question. So a different mild steel profile measuring 40 millimeters in length and 25 millimeters in width, featuring a phi 15 hole as depicted, is to be punched from a 5 millimeter thick mild steel plate. So the plate has got to be cut. It's just not the hole. The hole is cut, is sheared, while the hole outside the plate is being cut. So you've got to calculate the force required to punch the plate, assuming the mild steel has a shear strength of 300 megapascals. So the stress is equal to load over the area of shear, and so therefore the load is equal to stress times the area of shear, where the stress is 300 times 10 to the 6 pascals, because that's the shear strength of the plate. And the area of shear is the perimeter of this plate. So it is twice 40 is 80 plus 50. So the outside perimeter is 130. But then you've got to add the perimeter of the hole, because the punch is cutting through that as well. And so the perimeter is pi d. And so you've got 15 times pi. You've got to multiply it by the thickness and bring it to meters squared. So you multiply by 10 to the minus 6. And so you get the force required is 256.7 kilonewtons, which is equivalent to about 26 tons mass. So it's a fair force to punch that. And then you've got to calculate the compressive stress in the punch during the punching operation. So you've got to use a different area. You've got to use the area of the plate, which will be 40 by 24, and you've got to subtract the area of the hole and multiply by 10 to the minus 6 to bring it to meters squared. And so the stress in the punch will be 325.4 megapascals, which isn't too bad, because punches are generally up around 900 megapascals compressive strength. Question 25. Explain the purpose of the aramid honeycomb on these panels in using this formula. Now these are the Nomex honeycomb panels with carbon fiber on the outside. This is what they use in Formula One cars and planes, and so all the aramid phenolic honeycomb is doing is moving the outermost fiber away from the neutral axis to make it more rigid. And so that's how you answer the question. The external plates of rigid carbon fiber are extended away from the neutral axis of the panel by the use of aramid phenolic honeycomb, which is lightweight, high specific strength. It increases the bending strength of the panel, indicated by the increase in Y in the bending stress formula. You've got to relate it to the bending stress formula. Both phenolic and epoxy resins belong to either thermosetting or thermoplastic class of polymers. Identify the appropriate polymer class for these resins and explain the primary distinction between thermosetting and thermoplastic polymers. So you must be able to draw this, and it's in page 135 of the Engineering Studies workbook. You've got to say that thermosetting structures are heavily cross-linked, and a thermoplastic or a thermosoftening structure has no cross-linking. It has weak secondary bonds, and that's how you draw it. So you've got a beam here. It's a universal beam, and it's a symmetrical universal beam. So the neutral axis will go straight through the center. You've got to do a shear force diagram. So you've got to work out the forces here. You take moments about the pin joint, so you can work that out. Then some of the vertical forces. And then you just follow the force. Go up 10. So you've got 10 there, down 5, along, because it's not a UDL, and down 10. And if you come back up that value, you know you're right. If it was a UDL, these would be inclined. And the bending moment diagram, all you do is that the bending moment at that point there is 10 times 0.5, so it's 5 kilonewton meters. And the bending moment at that point there is 10 times 2. Sorry, it's at the bending moment at that point there is 5 times 2, which is 10 kilonewton meters. And you just draw it. And if this was a UDL, this would be curved. Next question. The universal beam is 200 high, and we know that the neutral axis goes through the center of it, the centroid, and you've got to calculate the maximum bending stress. This is just straight out substitution here, really, and so the bending moment is maximum bending moment you get from that there. So that is 10 kilonewton meters, and you've got to multiply it by 10,000. You can't put kilo into an equation. The outermost fiber is 0.1 away from the neutral axis, and you're given this. And see this here, it's given in millimeters squared, and you've got to multiply that by 10 to the minus 12 to bring it to meters squared. And so that's been multiplied by that. So it's 90 times 10 to the minus 6. So it's meters to the fourth, not meters squared, sorry, it's meters to the fourth. So the bending stress substituted in there, so it's only 11.1 megapascals. This was poorly done. Whenever you do a drawing, make sure that all of the views are in projection. I had one student draw the left side view up here and the front view down here. Now, that's a no-no. These are all, have to be all in projection. And when you do a section, you've got to use these arrows with thick dark ends to the section plane so that when you're looking along here, you see that with all this removed. And where it has been cut, you put the hatching in. That was an easy question for 5 marks. This is a pictorial drawing, and you can use freehand if you like, because it's a sketch, or you can use instruments to draw this. Make sure that when you're doing it, I only teach isometric, I don't teach oblique, but you can do any pictorial drawings, but make sure the circles are correct orientated. The use of bicycles in urban environments comes with challenges and benefits. Describe 2 challenges, 2 benefits of using bikes as a form of transport in urban areas. So here, once again, you've got to describe. 2 challenges include navigating congested traffic and ensuring safety amidst busy streets. Conversely, 2 benefits are reduced environmental impact through lower emissions, right? So if you just said it reduced environmental impact, that's not a description. You've got to add through lower emissions. Next question, calculate the tension in the chain when a force of 500 newtons is applied to this bike. I don't know what happened here, but the diagram has moved. So you've got 170, the pedal was 170 radius. So you say the force times 170, which is 500. So you've got 500 times 170. That's creating the clockwise moment on the pedal. And you've got the distance that the chain is 100 millimeters radius times the tension. So that's the tension that this pedal is putting on this chain wheel. And so you've got 500 times 0.17, which is a 500 newtons times the radius of 170 there, minus T times 0.1, which is your sprocket size, your chain wheel size, sorry. And so it's 850. Calculate the velocity ratio of the drive system. Velocity ratio is distance the effort moves over the distance the load moves. And you notice here that you've got 56 teeth here and you've got 22 teeth there. So the distance the load moves will be 56 over 22. That will be the velocity ratio of the system. And so the distance the effort moves is pi times 340, and which is 1.068, and the distance the load moves is the velocity ratio of the chain system times pi times 620, which is that diameter there. This 340 is twice 170, and so the velocity ratio is equal to 0.215. Calculate the mechanical advantage. If the efficiency is 75%, you know the mechanical advantage equals efficiency times velocity ratio. And so the mechanical advantage is equal to 0.16. And that's it. So I hope you'll go over these questions and get good at answering these, particularly the truss, because as I said, only a couple got the truss out. But good luck with it, and I hope you learned something from this lesson. Bye.